This is Growth and Decay by Nash and Bryce. The first problem was our linear growth problem, and it is at a swim fundraiser. Sally tells Mia she will pay $1 plus $3 for each lap that Mia swims. In my table, you can see that the start value is $1, and it goes up by $3 for each lap that is swim. The next now equation is next equals now plus 3, and the start value is 1, and my explicit is y equals 3x plus 1. And my graph, you can see it is linear because it is mostly straight, and it starts at 1 and just goes by 3 each time. My problem that I made is if Mia swam 17 laps, how much money would she raise in all? And if she raised 37, how much laps would she swim? And for the first one, I plugged in 17 for x and did 17 times 3 to get 51, plus 1 is the initial value to get $52 in all. For number 2, I did the equation and then did minus 1 to get 36 from 37, and then 36 divided by 3 to get 12 laps. My second problem is the exponential growth, and it is a small town and population of 2,000 when first recorded, and in 3 years the population is now 16,000. And in my graph, you can see by the start value is 2,000, and it doubles each year. My next now equation is next equals now times 2 to the x power, and start value of 2,000, and my explicit is y equals 2,000 times 2 to the x power. In my graph, you can see it's exponential because it gets bigger and bigger each time. It is not linear because it's not straight. My problem is what will the population be in 18 years, and how many years will the population be? 512,000. For number 1, I plugged in 18 for x and did 2,000 times 2 to the 18th and got 524,288,000 people. For number 2, I switched it around and did 512,000 divided by 2,000 to get 256, and then did 256 and plugged in 8 to the x to get 8 years.
This is my linear decay problem. You buy a party-sized bag of M&Ms. It has 200 M&Ms inside. Every minute you eat 2 of them. The first minute you eat 2 and are left with 198. The second minute you eat 2 more and have 196 left. As you can see in my table, you start with 0 minutes and have 200 in the bag. Every minute you go down by 2. My now next rule is next equals now minus 2 with a start of 200. In the graph, you can see that is linear because it goes down by 2 and it is very straight. My first problem is how many would you have to eat to get 180 M&Ms left? You would have to eat 20 M&Ms. If you ate 26 M&Ms, how many would you have left? 174 M&Ms is the answer. This is my exponential decay problem. You buy a new car that is worth $20,000. Every year, that depreciates by 18%. The first year, the car is down to $16,400. The second year, the car is down to $13,448. In the table, you can see that it starts at 0 years, and it is at $20,000. And it goes down 18% each year. The now next rule is next equals now times 0.82. The start is 20,000. As you can see in the graph, it is very curved and is going down drastically every year. My first question is, what would the car be down to at year 10? I did 20,000 times 0.82 to the 10th power. $2,748.96, or if you round it, $2,749. The second problem is if the car is down to 1,848.4, how many years has it been? And the answer to that would be 12 years.
Thanks for watching.